This section deals with different operations that we can make on functions. The first operation that we're going to look at is combinations of functions. Combinations of functions is really just adding, subtracting, multiplying, or dividing two functions, and we define it as such. Given two functions, f of x and g of x, we can determine the sum of the two functions by adding them together, the difference of the two functions by subtracting the functions from each other. The only thing you really have to think about when you subtract the functions is to make sure that you distribute the minus sign. You can multiply the two functions together, and you can divide the functions. So there's four different combinations, and they're the same operations that we have in mathematics: sum, difference, product, and quotient. Now, when we are combining functions, we're also going to be asked to find the domain of these functions. So how do you find the domain of a combined function? Well, the domain of a combined function is going to be the intersection of the domains of f of x and g of x, excluding any new issues. Well, what does intersection mean? Intersection means what the domains have in common. So they're going to intersect wherever they have something in common. Well, how would we go about doing this? Well, in order to find the domain of a combined function, you first need to know the domains of f of x and g of x and their intersection. After you do that, that's going to be your domain for your combined function, other than any new issues. Now, issues. When did issues arise? If we go back to the section we did before when we were talking about domains of functions, the only time we had issues is if we were an even root function or if we were dividing. Now, can I add two functions together and get them to end up being even root or all of a sudden rational? No. Can I subtract two functions and get them to be even root or rational? No. Can I multiply two functions and end up getting even root or rational? No. Quotient. Can I divide two functions and end up being even root or rational? Well, not even root, but I can end up being rational. So the only time you're going to get with new issues is when you're dealing with the quotient. So those new issues will only arise with the quotient. All right, well, let's look at a first example of combining functions and finding their domain. So it says to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x, and their respective domains. And for my first example, I'm given that f of x is equal to x minus 7, and the g of x is x squared plus 2. All right, well, let's start off by finding the domains, because I'm going to need them in order to find the domains of all the other functions. So let's start with the domain of f. Well, the domain of f, what is this? Well, it's just a line. Does it have issues? No, there's no even root and there's no denominator. So I know that the domain of f is going to be all real numbers, or that negative infinity to positive infinity. Let's look at it as a picture. As a picture, we shade the whole entire number line. What about the domain of g? Well, the domain of g, does it have issues? Well, it's a parabola. It doesn't have any issues. It doesn't have an even root. It doesn't have a rational. So the domain of g is also that negative infinity to positive infinity. And if, again, we just look at a number line, we'd shade the whole entire thing. Now, I know that you guys aren't going to be able to do this, but I just want you to watch it and see what we're doing. When I say the intersection, I mean what they both have. So basically, if I take this number line here and place it on top of the other number line, where do they intersect? Well, I'm green and red shaded everywhere. Right, so that means that they intersect everywhere. So all real numbers intersects all real numbers everywhere. So the intersection, that is shown by this upside down U. So the domain of f intersected with the domain of g would also be all real numbers, or negative infinity to positive infinity. And again, it's easy to see if you place one of the number lines on top of the other number line. Everywhere everything is shaded is going to be their intersection. Right, so I know what the domain of the new combined functions is going to be unless new issues arise, but let's go ahead and find those new functions and then state those domains as we go. So the first one, again, we're adding them. So I need to add f and g of x. So in order to add f plus g of x, all I need to do is take f of x, which is that x minus 7, and I need to add it to g of x, and g of x was my x squared plus 2. Combine like terms where I can, and I get that f plus g of x is equal to x squared plus x minus 5. So that new function, this combined function for adding, is x squared plus x minus 5. The domain of this function, f plus g is going to be that intersection. And no issues arose when we added, so it's just going to be that negative infinity to positive infinity. Let's see, subtraction. Same thing, f minus g of x. Well, that's going to be f of x. Well, remember my f of x is my x minus 7. Subtracted from my g of x. Remember my g of x is this x squared plus 2. Well, the reason that I've placed that x squared plus 2 in parentheses is I need to make sure that I distribute my minus sign. So let's distribute the minus sign and then combine like terms. So you're looking at negative x squared minus 2. If I combine like terms here, I get that f minus g of x is equal to negative x squared plus x minus 9. Well, did I create any new issues by subtracting? No, so the domain of the newly combined function is going to be that intersection, so the domain of f minus g is going to be negative infinity to positive infinity. Let's look at the next one, multiplying. In order to find f times g of x, I need to take f of x, which again is my x minus 7, and multiply it by g of x, which again is my x squared plus 2. Well, if I FOIL this out, I end up with x cubed plus 2x minus 7x squared minus 14. Well, placing this in descending order, we get x cubed minus 7x squared plus 2x minus 14. Now, did we get any new issues by multiplying these functions together? No, we didn't. So the domain of f times g is going to be that intersection, which is negative infinity to positive infinity. All right, let's look at the next one, f over g. So we take, in order to find f over g of x, we take our f of x, which is my x minus 7, and we divide it by my g of x, which is my x squared plus 2. Well, there's nothing that I can do there, but now I have to think, did I create new issues? Well, I don't know. This is a rational function, so I need to determine if there is any new issue that arose from this. Well, the way that we found domains for rational functions is we set that denominator, in this case x squared plus 2, equal to 0 and solve for x. Any real number we get, we end up having to exclude. So I subtract 2 from both sides and then take the square root. Well, I get that x is equal to plus or minus I square roots of 2. Well, is this a real number? No, it's not a real number. This means I don't have new issues. And because I don't have new issues, then the domain of f divided by g just stays as that negative infinity to positive infinity. All right, let's look at example 2. Example 2, same thing, find the new functions by adding, subtracting, multiplying, and dividing, and find the domains of these new functions. Okay, well, let's start, remember first, by finding the domains of the given functions. So what's the domain of f? Well, this is a rational function. So in order to find that domain, I need to set the denominator, which is x minus 4, equal to 0, and solve for x. I get x is equal to 4. So if we thought of it as a number line here, we're just going to call this the domain of f. At 4, I would have an open circle, and then I would be able to shade everywhere else. Okay, well, let's do the same thing for g. Well, for g, I would set the denominator, which is x plus 5 equal to 0, solve for x, and I end up with x is equal to negative 5. So the domain of g would be all real numbers but negative 5. So here's negative 5 on a number line. It'd have an open circle, and then I would shade everywhere else. Well, what's the intersection of these? Again, basically, if I take my number line and place it over the red number line, what do they both have in common? Well, if you look here, they both have all the numbers in common except for negative 5 and 4, because one has a hole at negative 5 and the other one has a hole at 4. So the domain of the intersection here, the intersection of f and the intersection of g's domain is going to be, I'll draw a new number line for this, all numbers except for negative 5 and 4. Well, what's the interval notation of this? Well, the interval notation of this would be negative infinity to negative 5 union negative 5 to 4 union 4 to positive infinity. So the domain of the intersection is negative infinity to negative 5, negative 5 to 4, and then 4 to infinity. That is the intersection, or that is the domain that's going to be the domain of my combined functions unless a new issue arises. And again, the only time a new issue is going to arise is when we divide. So let's go ahead and start finding these new combined functions. So the first one tells me to add, so I'm going to add, so f plus g of x is going to be f of x, which is my 3 over x minus 4, added to my g of x, which is my 1 over x plus 5. Well, these are rationals. So in order to add fractions, we're going to need a common denominator, and our common denominator is going to be x minus 4 and x plus 5. So let's make those equivalent fractions. My first fraction is missing the x plus 5. If I multiply 3 times x plus 5, I get 3x plus 15. My second fraction is missing my x minus 4. If I multiply 1 times x minus 4, I get x minus 4. Adding the numerator now, f plus g of x becomes 4x plus 11 over x minus 4 times x plus 5. Now, what is the domain of this function? Well, the domain of this function, remember, is going to be this intersection with any new issues. Well, I can't make new issues by adding two fractions together or by adding two functions together. So the domain of f plus g is going to stay that intersection. And again, that was negative infinity to negative 5 union negative 5 to 4 union 4 to positive infinity. Let's look at the next one. The next one's asking us to subtract the two functions. Well, f minus g of x is going to be my f, which again is 3 over x minus 4, subtracted by my g, which is 1 over x plus 5. Well, in order to subtract fractions, again, I need a common denominator. Well, my common denominator, again, is going to be that x minus 4 times x plus 5. So let's put both of those over my x minus 4, x plus 5. Well, the first fraction is missing my x plus 5. If I distribute, I get 3x plus 15. Well, the second fraction is missing that x minus, I apologize, there should be a minus sign between them. X minus 4, if I distribute, I get x minus 4. Well, the only thing that we need to distribute additionally here is this minus sign, so that becomes minus x and plus 4. So once you combine like terms, f minus g of x is going to be, well, 3x minus x is 2x, and 15 plus 4 is 19, all over my x minus 4 times x plus 5. Great, well, what about the domain of this function? Well, did any new issues arise when I subtracted them? No, so their domain is this intersection. So the domain of f minus g is going to be that negative infinity to negative 5 union negative 5 to 4 union 4 to positive infinity. C says multiply them. Well, f times g of x is going to be my f, which again is 3 over x minus 4, times my g, which is 1 over x plus 5. Well, you multiply fractions by multiplying numerator times numerator and denominator times denominator. So 3 times 1 is 3, and the denominator I can keep as x minus 4 times x plus 5. Well, did I make any new issues by multiplying? No, I did not. So the domain of the multiplication is going to be this intersection. So the domain of f times g of x is going to be negative infinity to negative 5 union negative 5 to 4 union 4 to infinity. All right, let's do the last one, f divided by g of x. So this is going to equal f of x, which again is my 3 over x minus 4, divided by, and I'm just going to put a little division symbol here, g of x, which is 1 over x plus 5. Well, in order to divide fractions, I multiply by the reciprocal, so f over g of x is equal to 3 over x minus 4 times, well, the reciprocal of 1 over x plus 5 is x plus 5 over 1. If I multiply numerator times numerator and denominator times denominator, I get 3x plus 15 over x minus 4. Well, did I create any new issues here? Well, I don't know. This is the rational function. Let's see if there's any new issues. How do you figure that out? You set that denominator, x minus 4, equal to 0, and you solve for x. Well, I get that x can't be 4. Is that a new issue? No, it is not a new issue. It was already excluded. The number 4 is already excluded from the domain of the intersection. So this is not a new issue. Because it's not a new issue, I don't have to add any exclusions to my domain. That means that the domain of f divided by g is going to be that original intersection of negative infinity to negative 5 union negative 5 to 4 union 4 to positive infinity. The next video is going to deal with composition of functions.